Okay, welcome back. So we continue with question number 2. In the previous video, I tried to give you an intuitive understanding, and so I'm just going to take it from there. If you didn't get anything, try to go back to the previous video, or you can leave your questions below, and then I'm going to answer it as best as I can. So in this video, I'm just going to go straight to answer the question, continuing from where we left off last time. Okay, so again, f of x is this. I've already written it. Why do I repeat it? So let's y is equal to x plus 3 all squared. Again, like I said at the time, you should always try to picture them on the x and y axis. That way you are able to really imagine the slope changing, stuff that I explained, and so on and so forth. So we can expand this to get x squared plus 6x plus 9. Okay, so now in differentiating from first principle, the underlying assumption is that we let a small change in x give rise to a small change in y. Now this expression is very important. This is really, one of the main things that make derivative from first principle, this assumption. This is really to test your understanding about how derivatives work. After this, I'm going to show you a straightforward way of finding the differential of this expression without having to go through what we're about to go through. But in order to get full marks, you have to do everything that we are about to do. Okay? Alright. So let a small change in x give rise to a small change in y. So this means that y, first of all, is equal to x. See, we are saying it's small change in x. There's a small change in x. So x squared here, we're going to say plus change in x all squared. This is important. Plus 6x plus change in x, and then plus 9. Alright? Again, that change in x must give rise to a change in y. So plus change in y here. This is really important. Since we are saying a small change in x will give rise to a small change in y, wherever we find x, we replace it with x plus change in x, and so y also becomes y plus change in y. So let's do some algebra. So we have y plus change in y is equal to x squared plus 2x change in x plus change in x squared plus, now expanding this, 6x plus 6 change in x plus 9. Okay? Alright. So is there anything else we can do with this? Not really. Okay. So now, once you have these, you have implemented this, every small change in x gives rise to a small change in y. Now remember that for the derivative, we are looking for how the change in x and y occurs, because slope is basically change in y and change in x. So when you track the change in y and x, you are basically invariably tracking how the slope changes, which is what you are looking for in the first place. So what we are going to do is that we are going to try to find the change in y. Straightforward, we just make change in y the subject here. So change in y is equal to this whole thing, and then we just bring y to the other side, is equal to x squared plus 2x changing x plus, this is becoming very long, and you should actually get used to this when you are doing calculus. The things get really ugly. Plus 6 changing x plus 9, and then minus y. Let me just write it better. Sorry about that, guys. I'll make it right. 9 minus y. Now, but y is equal to this. But y is equal to x squared plus 6x plus 9. So we replace this with all these. Yeah, I know it is getting really ugly. Don't worry, the answer will be nice. Okay, so changing y is equal to x squared plus 2x changing x plus changing x squared plus 6x plus 6 changing x plus 9 minus x squared plus 6x plus 9. Now we open this bracket. So changing y is equal to x squared plus 2x changing x plus changing x squared plus 6x plus 6 changing x plus 9 minus x squared minus 6x minus 9. Remember that when we open the brackets, the minus really, affects every single thing in here. So positives become negative and negatives become positive. Anyways, so now that we have this, and watch, there's plus x squared minus x squared. There's plus 6x minus 6x, and there's plus 9 minus 9. So as you can guess, this will take this away, that will take that away, and this guy will take that away. So what do we have left? Changing y is equal to 2x changing x plus changing x squared plus 6 changing x. Okay? Alright. This is beautiful, isn't it? Alright. Now remember again that we are looking for the change in slope, not just changing y. Now what is slope again? Slope is changing y over changing x. So we only have changing y here. So we divide through by changing x, right? Changing x, changing x, changing x. Alright? So as we can see, this will take this away. This is squared, so it takes away one of it, and there's only one changing x left here. And then we have this goes away with that. Now I'm going to clean this side. I hope you guys don't mind. I don't have lots of space here. Sorry. Okay. Okay. Alright, almost done. Alright. So what we have left is changing y divided by changing x is equal to 2x plus changing x plus 6. Okay? Alright. Now, at this point, see, this is basically how the slope changes. But then we now want to apply the idea of limits. Alright? Because like, why do we, apply limits, and things of that sort? You see, our curve is changing. The slope on it is changing, right? And you see, even though when I, said that, let's assume that these 2 points, since it's almost on a straight line, we just assume it's on a straight line, but in reality, it's actually just a curve, right? But you realize that the closer these 2 points are together, the closer they are together, the closer that the space between them is to a straight line. Yeah, so hypothetically speaking, if the difference between the 2 points is 0, then we should actually have a straight line. At that point, we can actually determine the slope. So that is why we are going to find the limits such that the limit of changing y changing x as changing x approaches 0. You see, meaning we are reducing the gap so that it gets closer and closer and closer to a straight line. The same for the other, the same for the other, the same for the other ones. Understand? So the limit as changing x approaches 0 is, so we now look within this equation. Wherever we find changing x, we put 0. So this becomes 2x plus 0 plus 6. Now this expression, the limit of changing y over changing x as changing x approaches 0 is what we call the derivative dy dx. And this is equal to 2x plus 6. And that is our final answer. That is the derivative from first principle of x plus 3 all squared. Alright? Okay. Now, in order to find the derivative from first principle, you have to really go through all of these. All of what you did. Remember? First, because this was in the brackets and stuff like, we first expanded the brackets. And then we let y equal to that expression. And then we let a small change in x give rise to a small change in y. We physically wrote that expression because, as I said, it is the assumption underlying the derivative from first principle. And then from then, you just add your changing x's and then changing y's, and then you do all of these manipulations. You can just rewind and rewatch until you understand it. If you have questions that I didn't tackle, you can ask them in the comment section below. Believe me, I go through every single comment that comes. So rest assured, I will see it and I will respond however appropriately, hopefully. Okay, so this is how to differentiate from first principle. Alright, now as I said, there's actually a shorter way of finding the differential of an expression, but that way is not first principle. Alright, so I'm going to show you that way very quickly, and then you can use it to verify your answers. Okay, so I'm just going to, this question is answered, right? So I'm just going to clear the space. And then, now whenever you are given, let's say y is equal to x squared, right? Now watch, the derivative of this is actually dy dx is equal to 2x. If y is equal to x cubed, dy dx is equal to 3x squared. Now you're probably wondering, how am I getting this? Just watch closely. Y is equal to x to the 4th. Dy dx is equal to 4x cubed. Now you're seeing the pattern, right? When y is equal to x to the 5, dy dx is equal to 5x to the 4th. You see the pattern now, don't you? See, when y is equal to x squared, to find the derivative, that power you bring it down, and then you reduce it by 1 up here, and then it becomes 1 here. Same thing, it's 3 here, then we bring it down, and then we have this, and then we reduce it by 1 to maintain what is left. Similarly, 4, bring it down, reduce by 1, and keep it there. And that is how to find derivative straight away, right? Also, if they were expressions, full expressions, right? So for instance, if you have x, oops, what am I writing here? What am I saying? X cubed plus x squared plus x plus 3, right? Let's say y is equal to that. Now dy dx is equal to, so you take them one by one and apply what we just did. So for x cubed, meaning you bring 3 down, and then x, you reduce this by 1 to get squared, plus you do the same to this guy, 2x to the 1, but we don't write 1, plus, now watch closely, this is to the power 1, right? So what do? We bring it down 1, and then we reduce this by 1. This becomes 0. X to the power 0. What is x to the power 0? Any number to the power 0 is equal to 1. Even 1 million to the power 0 is equal to 1. You must remember that. You probably already know that anyway. So if it is 1, 1 times 1 is 1. So this becomes 1. Plus 3. Now here you have to assume that there is x to the power 0, right? And if there is x to the power 0, okay, now whenever there is a constant, whenever there is a constant and you're finding the derivative, it always gives 0. So this gives 0. So remember, the derivative of even 1 million is 0. Alright, so this gives 0. So the derivative of this expression is this right here. So now the question given to us was f of x is equal to x plus 3 all squared. Remember, we expanded it to get x squared plus 6x plus 9. Now the derivative of this, if we apply what we just learned, we bring this down, we get 2x plus this, remember, is 1. So we bring 1 down, and we have to multiply it by this guy here. So 6 remains there, and this minus 1, 0, so 1. So that's just the same. And this is a constant, so plus 0. So this is equal to 2x plus 6. And if you remember, that was our answer. So this means our derivative from first principle was correct. Anyways, this is the end of question number 2, and it's really took a long time to answer question number 2, but I hope it was worth it. So like, share, subscribe, whatever it is they do to videos on YouTube. And if you have any questions, comment below. I will surely see it, and I will see you next time. Bye bye.